This is one of my favorite sections in the entire course to teach, and I really think it's because there are so many great nuts and bolts in here, things that when you know them, not only can you improve your exam performance, but you can really improve your performance as a network troubleshooter. You are going to use the information in this section for the rest of your Cisco routing and switching career. You may go into a job where maybe you're not touching switches that often, or maybe you're not touching EIGRP often if your network doesn't run it, but you're going to be, everybody runs the things we're talking about in here, and you're definitely going to be using this info for a long time, starting with your CCENT and CCNA exams. Also, we're going to get to tear a little stuff up here. We're going to take a router and a switch. We're going to do some reloads, maybe a little write erasing, that kind of thing. Things that you don't exactly do on an everyday basis in your network. At least I hope not. So let's go ahead and dive right in here and talk first about these memory components. And these are the same for routers and switches, but I'm not going to say routers and switches 500 times. I'm just going to say routers. But when it comes to ROM and flash and RAM and NVRAM, between routers and switches, they are the same thing. Now, we need to see what's contained in each of these, and also be very careful to note what is retained and what is not retained on a reload. For one, we know that's going to pop up on the exam, and secondly, there's nothing worse than thinking you've saved your work and then you find out that you haven't. So we need to know, what's going to be retained and not retained on a reload. With ROM, the read-only memory, here you're going to find the router's bootstrap startup program, the operating system software, and a little something called the POST, the Power On Diagnostic Test Program. Then we've got Flash. And the full name, of course, is flash memory, but this is very important because you're going to find important files here, especially the iOS image files themselves. What this is, it's erasable and reprogrammable ROM, and flash memory content is retained by the router on a reload. Now, with random access memory, or RAM, this stores operational information such as routing tables and the running config file, the running configuration file. Now, these contents, the contents of RAM, we're going to lose when we reload the router. So we're going to lose our routing tables. They're going to have to reform when the router comes back up, and the running configuration file is lost. Now, non-volatile RAM, the name is the recipe. It's not volatile. You are not going to lose the contents when you power down the router. This is where the startup configuration file is held. And you can see I'm already starting to draw a very important distinction between our startup file and our running file, and we will revisit that throughout this particular section. Just a couple of important comparisons. I know I just went over this, but it bears repeating. RAM contents are lost on reload, where NVRAM and flash contents are not. NVRAM holds the startup config file, and RAM holds the running config file. Now, we're going to go back to those files, the startup and running, once we have a device started up and running. But what we're going to do here is take a look at the boot process and then talk about something called setup mode. Sounds so innocent. When a Cisco router first powers up, what it does, it runs a series of power on self-tests, or POS. And again, the name is the recipe. These are diagnostic tests designed to verify the basic operation of the interfaces, the memory, and the CPU. Basically, what the switch is doing, or the router is doing, when it runs a post, it's just checking things to see if it's even worth starting the entire boot process. Because there are certain things that if they are broken, physically or logically, there's no use to even go through all the steps. Obviously, if your memory is corrupt for some reason, then it's going to tell you, hey, there's no use in me booting up because you got a memory issue. Depending on the model or router you're running, you can see some of these tests. And what I've done is I've already reloaded a 2950 switch. Let me bring that up, and I'll bring a 2960 up at the end of this video, or the end of the part of the course, just for comparison's sake. But let me go up to the front here, and here's where I did proceed with reload. You're always going to be asked, when you type in the word reload, you're going to be asked, do you really want to do this? Which makes sense. Now notice that there's a single word in the brackets. This is an important distinction. Whenever a Cisco device asks you a question, it is going to prompt you with an answer, sometimes two. If it gives you one answer like this, confirm, all you have to do is hit enter and it's accepted. As you're going to see shortly, there are other questions where we are asked yes, no. And we can't just hit enter. We have to really put in a Y or an N. We have to say, yes, this is what I want, or no, it's really not what I want. And it's a 2950 switch, and you see a couple times it's mentioned here. And it's going to go through its process, base Ethernet, MAC, initializing flash, etc. And it's going on down here, and then you'll notice after flash, C2950I, 6Q4L2-MZ, etc., you see all these pound signs. That means that the file is being uncompressed and installed. And what will happen is when you reload a router, when that starts happening, you'll see the little pound signs start to appear on the screen. They're not all going to appear at one time. It's going to be one at a time. Now, sometimes this goes pretty quickly, and sometimes it goes pretty slowly, depending, of course, on the size of the file and some other factors. The only time you have a problem is when those pound signs stop appearing. You know, and you get like a couple of rows and it just stops for a long time. Then you've got an issue. But here, thankfully, all the pound signs kept scrolling. I've got the font really turned up so you can't see all the window, but you can see it's just a huge series of pound signs. Then it's going to give you a little warning about what you can and can't do. Then we've got the version, we've got the resoftware, iOS software, when it was compiled, etc. And here are the posts that I mentioned. Now, not every post the device runs is going to be shown on the screen. I do not know the exact scientific method of why they show some and why they don't show others. But you can see here, system board test passed. Sounds good to me. Ethernet controller test, again, sounds good to me. We see a front-end loopback test. And that's about it. And you can see, I also like this one, last reset from system reset. It says, hey, here's why I reloaded. And then press return to get started. So that's what I did, and in a few seconds what you see is all of this information scroll up. And if you have any little problems in spanning tree or anything else, you might get some messages there about it as well. But right now we're concentrating on those posts and exactly what those are and what they do. Now, another big thing that posts find out very early is if a fan is broken. That's probably the number one post. Actually, it is the number one post result, bad post result I've run into over the years. It's going to tell you it's an environmental factor, and it gives you a message on the screen that pretty much says, hey, you know, we're just, you know, sure out of luck because I'm not going to bother booting because I got a broken fan or I got this problem. And once you see that post the first time, you just, you know, moan and groan, and then you just get to work and get it troubleshooted. But here, we're assuming that our fictional router has a good fan, which our real router did as well, and it's going to move forward. Now, after the router passes the posts, it looks for a source from which to load a valid iOS. And we saw that as well. Let's go ahead and bring that up one more time. Up here. And here it is, and it starts saying loading flash. Now, all these numbers actually mean something after this, but we don't have to go into that yet here at the CCENT exam level, thank goodness. So we've got loading flash. Here's the file it's loading. And it looks, you know, it said loading flash. So that's where it's loading the file from. That's actually the first place that the device is going to look for the iOS. It's going to look for flash. That in flash, that's the default. We can also have it load from a TFTP server, a trivial file transfer protocol. Sounds like a throwaway protocol, right? Like something you're not going to use very often. You are going to use a lot of TFTP servers in your Cisco career. Usually it's going to be your laptop because you can get free software or almost free software. I've run a free program for years. That's worked very, very well for me. So TFTP, and the third spot is read-only memory, and that's the last resort. If a router can't find its file, an iOS image in flash or a TFTP server, then it's going to pull one from ROM. Now we can change that order. To do so, we have to make a change to the configuration register. I'm going to show that to you in this part of the course. For now, the only thing I want to say to you, it's similar to the Microsoft registry in that you should never change this value unless you're really sure of the result. You have to be very careful about that. Now, once the iOS is found, now we need something else. We need a startup configuration file. And what happens here is that by default, the router is going to look for the startup configuration file in non-volatile RAM, NVRAM. Now, if there's no startup file there, the router is going to look for a TFTP server again that has a startup file. If no valid file is found in either one of those places, the router is going to prompt you to enter setup mode, where the router runs the system configuration dialog, and it's a series of questions involving your basic setup. A lot of questions. And you'll notice on the screen, I even call the section setup mode, the CLI, and pain. Because when you take a Cisco router out of the box and you boot it up for the first time, it's just dumb. It's dumber than a sack of rocks because you haven't told it anything yet. The router can't possibly know, oh, well, these are Chris Bryant's networks and these are the services he wants to run. I mean, when they're getting that good, we'll all have chips in our head. But for now, we have to put this information in one of two ways. And we can use setup mode, or we can manually configure all of that information at the command line interface, or the CLI, or the CLI. Seems like a pretty simple choice, right? I mean, you look at this and you say, of course I'm going to use setup mode. Why would I go through this manual thing at the command line, etc.? Well, by now, even if this is the first course you've ever taken with me, you know that I am all for automating processes and letting devices dynamically learn things that we could configure statically. MAC addresses, first thing we looked at really in a lab here, and we could build a MAC address table on a switch statically, but why would we? It's so much more efficient to let the switch build it by looking at what value again? What's the first value? Source MAC address, right? Absolutely. Now, it's not because I'm lazy. It's because I'm smart. And you're going to do the same thing because you're smart. Allowing dynamic learning is almost more efficient every single time than startup configurations. However, setup mode is not dynamic. It's not something that you let run and it goes out and looks at your network and says, oh, here's the way that Chris or Sally or Jim wants the router set up. There's no way to do that. So you're going to answer a series of questions, a very long series of questions where it seems like one question begets 5 others. Now, we're going to see this in action. I don't want to just badmouth it here. I want to badmouth it while we've got the router open. Seriously, some people like setup mode. That's fine. Most people configure from the command line. And I think you'll see why. As a matter of fact, I know you'll see why when we look at it live. Now, you're going to be presented with a very simple question when you begin setup mode. And if you answer yes to that question, this is one of those yes-no deals I was talking about, you're going to enter setup mode. And again, just reiterating, it's a fancy way of saying the device is going to ask you a lot of questions about what you want and what you don't want. If you answer no, the router is going to say, oh, okay, I'll just finish my process here, and then in a few seconds or a minute or so, it's just going to dump you at the command line. And you're going to be sitting there with router and a little arrowhead and a flashing cursor. That's it. So setup mode sounds like it's going to be pretty good, right? Well, there's, again, nothing wrong with choosing setup mode, but I've seen many admins, they get tired of answering questions in a few minutes. It's like you feel like you have to answer a question about everything the router can possibly do, because you do. And you're thinking after about a minute or so, it's like, man, I don't want to do it like this. Just get me out to the command line. I usually last about 30 seconds with setup mode. And what we will do on the very next video, I am, during our break here, going to write erase a router. We're going to reload it, and then I will bring it up, and when it comes up to that prompt of the yes/no question, that's where I'll bring it back up on the screen. In the next video, we'll go through setup mode ourselves, and then I'm going to show you something that a lot of people don't know. I'm going to show you how to get out of it, and I'll see you on the next video with that.